Thank you everyone for joining us at 5:30 on Thursday. Hopefully you have libations in your hand. Those are allowed in the room. Right next door, but please wait till after the presentation. So today we're going to talk about Amazon Simple Workflow. And why are we here? Why are you in this room? All of us in this room probably have use cases that require great resiliency and scalability. You need to be able to build applications that coordinate, track, and audit programs with multiple steps on multiple machines. The customers you see with me today will talk about use cases similar to those, and use cases that require those sorts of features and capabilities. So let's talk about one of these multi-step processes. How many of us booked our own travel to Vegas? Right. I'm in that boat too. So this behind the scenes is a multi-step process. You may have a database on a reservation site that is updating the seat inventory with available times, available seats. And then you may have initiated a search for a flight, either by web, mobile, or SMS. You might have then selected seats, provided your credit card information. The system would then have tried to confirm that the inventory was still available. In the case that someone else may have selected that exact seat and flight combination, you would have then confirmed your trip. The system would have finally updated the inventory to make sure that that combination was no longer available, and at the end send out a confirmation email and hopefully guaranteed you a seat when you showed up at the airport. So how would we make this reliable, scalable, and audible? This would work for a handful of users. How would we make this scalable for tens of thousands, hundreds of thousands of users? Well, we could take our logic and condense it into an application server. And then we could scale that out by having multiple application servers communicating with multiple databases. But what happens if one of those databases should happen to fail? What happens if an application server would happen to go down? How would you know the state of your application? How would you know the state of the customer's workflow in booking that flight to come to Vegas? How would you handle these challenges today in this distributed world where you have multiple nodes, multiple steps, and multiple machines? Well, that's where Simple Workflow comes in. Simple Workflow provides customers with three fundamental components to be able to handle these kinds of issues. We give you a control engine that manages your state in the cloud. We route your tasks and distribute the load based on this control engine. We give you HTTP APIs to build your logic on top of the control engine. And then we offer a programming framework that's a higher level abstraction on top of the APIs in Java and Ruby. So our customers today will talk about their use cases. There are a couple of key Simple Workflow concepts that I'd like to share with you so that you can kind of relate to what they are going to present. One is this concept of a decider. In Simple Workflow, a decider is the control logic that you write for your application. It's your secret sauce. It's the magic that makes your stepwise application go, whether it's sequential or parallel. An activity worker are the discrete units of work that you have to perform. So if we go back to the travel booking example, the entire process would be considered your decider, the transitions from step to step. And then a discrete unit of work, the activity, is what we call the activity. So let's talk about Simple Workflow customers in general. They may look a lot like your companies and what you all do. They're privately held, venture-backed, publicly traded. They use a range of programming languages: Java, Ruby, C#, Scala, Go. PHP. They run on-premises, and they run fully on AWS. So the deciders and the activity workers that operate in a simple workflow, you own. You can host them wherever you want, in the AWS cloud or in your data centers. Customers also come from a range of different industries, maybe similar to the industries that you're in: media, e-business, retail, finance, life sciences, gaming. The list goes on and on. They also have many use cases: batch processing, transcoding, content delivery, MapReduce. Perhaps you're familiar with many of these use cases in your organization as well. But what do our customers have in common? They have multiple steps running across multiple machines, which means there's a higher potential for failure on any one of those nodes. And it means they need resilience, scale, and auditability of their applications. And that's where Simple Workflow comes in. So the customers we have today are from Bazaarvoice, Lyft, Bazaarvoice, GolfTech, Cardspring, and MemberSuite. I'll discuss Lyft, Fluid, and ConnectWise later in the presentation. I'd like to invite them up to speak about their use cases. And first, I'd like to present to you Joe Pollard and allow him to talk about what they're doing at Bazaarvoice.
All right. Thanks, Sanjay. I like being out here. Love talking about SWF, so thanks for having me and thanks for your attention. I'll talk to you first about who Bazaarvoice is. How many of you have used the internet before? A few. To purchase, maybe to shop online? Nobody? Okay, so somebody down here. So you've probably seen our software in action. We're the company behind the product ratings and reviews on thousands of websites around the world. So you've probably seen our stuff in action. You go shop for a Sony TV on Best Buy and you see 4.2 stars, 350 ratings. That's all hosted by Bazaarvoice. Submissions come into BV, we moderate them, we syndicate them, and we display them later. And we do this on a large scale. We have got hundreds of millions of different pieces of content in the system. We get billions of requests on a given week, tens of billions in a month, it says here, hundreds of millions of unique visitors. As you can, we have a footprint across this wide number of clients, so we get tons of requests. And you might even think that building a ratings and reviews system, how hard can that be? I mean, all you have to do is take user-generated content and display it. But one strategic advantage or a few strategic advantages for Bazaarvoice are our authenticity pledge. We have some really good fraud and spam detection. We have the ability to moderate the content, so we know that it's appropriate, that it's relevant, that's related, and not profane in any way. And we also have the ability to syndicate the content across our wide network. So the moderation system, that's what I want to talk about today. So we've had moderation for the whole lifetime of Bazaarvoice. We've been around about 7 years. And since the beginning, we've done moderation. A piece of content comes in, you might submit a question or an answer or a review, and it comes into the system and it's actually seen by a moderator. The moderator looks at it, might highlight a piece of the text and say, oh, there's a shipping issue here, and let's go ahead and tell the retailer about the shipping issue or customer service issue. Or they might say there's a product flaw, let's tell the manufacturer to fix their product. Or they might just find that this review is totally unrelated, it's bogus, it's spammy or something. And can reject it altogether. After that moderator reads the content, then another moderator will proof that content, that decision, make sure it's good to go. And then it'll go live. And that's cool, it's a good feature set. But the original CMS1 content moderation system had a few kind of design problems. It was pretty latent. The content comes in the system and it has to be, it might be in a long queue, it has to be given to 2 different moderators, which are scheduled every 4 hours. So we see days in terms of turnaround time on a given piece of content. We also had a multi-cluster environment, many different distributions, deployments of this application. And so a given moderator would have to come log into 7 or 8 different systems to actually see what work they had to do today. And in addition to that, we acquired a new company, so we have additional moderation work. So anyway, what we wanted to build was a system that we could really understand the full scope of our moderation activities at Bazaarvoice. So we built CMS2, which is moderation as a service under the covers. It's one service built in Java. It's a web application and also a RESTful web service. Somebody submits content to it. We store it off into our RDS database, and then we actually began a workflow execution in Simple Workflow. And Simple Workflow here is very important because it gives us the ability to have a dynamic workflow execution that we can actually make decisions about which activities need to happen next. So we were able to decouple our actual moderation activity from the system that's bringing the content in and also from the different activities that have to happen. So like I said, we wanted to, we have a pretty straightforward moderation kind of process. Our workflow is it comes in, the decider picks it up, decides that the processing needs to occur. After that's done, proofing needs to occur, optionally. And after that's done, it's ready to go. And we didn't pick Simple Workflow because we have a really complex workflow. We picked it because we want the ability to grow our workflow, to mess with it, to have experimentation, to do something different tomorrow than we did yesterday. In the old system, everybody knew about the state transitions of CMS1. It was in processing unassigned, so you can't touch it. Or it was in proofing assigned, so you know it's assigned to a moderator for proofing, so you can't touch it. It's only when it's in this one magic state that you can actually make use of it. And so we've been able to pull that all out by using Simple Workflow. And case in point, when we wanted to actually, our data science team went off and did an experiment, and we're able to determine that with a really good level of accuracy for a certain type of user-generated content, they could predict that, in fact, this was going to be approved using NLP algorithms. We have 7 years of training data. Why can't we throw NLP at this? And in fact, they came away with a good model. And so in order to enfold the NLP system into CMS2, the change was we go to the decider, add a new if check. If we haven't done NLP on this, then do it. We add a new activity worker, which simply calls their API. And in a couple hundred milliseconds, it replies back, yes, in fact, this can be auto-approved, and we just finish the workflow. Or no, it can't, so we just continue with the workflow. So it's that kind of thing that really provides us benefit, but also that gives us new abilities to innovate on behalf of our clients. We can do new experimentation. If two moderators are looking at the same content and we compare the results, maybe we get better results overall. And that kind of experimentation. So I just want to leave you with a couple stats. We've seen over the past year, since this has been live, 75% throughput increase on the amount of content that's actually flowing through the system. For a given moderator, they can actually service 25% more characters per shift. And for a given piece of content, as you see on the screen, once it enters the system, it spends a third less time actually in the system before it's published. And a lot of that is due to the way that we're using Simple Workflow. So I'll turn it back over to Sanjay. Thank you.
So thank you, Joe. So next, I'd like to invite Ryan Ayers from GolfTech to talk about how GolfTech is using Simple Workflow. Ryan?
Thanks, Sanjay. Quick show of hands here. How many golfers do we have in the room? It's about right at a tech conference. So my name is Ryan Ayers. I'm the Vice President of Technology at GolfTech. Basically, I'm the head nerd in charge of two distinct groups. I'm the talented software developers and then also our infrastructure and support. So who is GolfTech? GolfTech's a leading golf instruction company. We use technology to teach golf, basically indoors and some outdoor facilities. From a market share standpoint, we have taught about 25% of all golf lessons taught in the US last year, and our next best competitor, we believe, taught less than 1%. So we're really the dominant player in this space. As you can see there, we taught our 4 millionth golf lesson in April of last year, and if things keep going how they are, we'll be teaching our 5th million here in the next calendar year. We have some fantastic strategic partners in Sports Illustrated, as most of you have probably heard, and then Golfsmith, who's a large retailer. And from a technology standpoint, we are a large PHP-based shop, and that's what our workflows are written in. So some of you were here early. We have a fancy video that we can't play, so just pretend that something really cool just happened. You guys are super excited about it, but we're going to talk about MyPro2Go. MyPro2Go is basically our virtual golf lesson offering. So in addition to 185 locations in the United States, Japan, Korea, and Canada, we also offered a virtual golf lesson, and that's a partnership with Sports Illustrated. So we're going to talk about that as a use case specifically for us, and talk at a very high level at some of the things that this app does, which are also very similar to what we do inside of our centers. So at a very high level, we capture a video. It gets uploaded. At the time that it is uploaded, we kick off Amazon workflows. They get pre-processed. Videos from the users are oftentimes different. They're flipped upside down. They're not scaled correctly, so we do some of our own proprietary pre-processing. We use a telestration tool, which actually gives the golf lesson, and I have a screenshot of that here in a second. We update the customer's account. We do some post-processing, and then we provide them what we call as a web lesson, so basically their golf lesson. So this is the telestration tool that we use, and it's more golf-centric than anything, and the buttons and functions inside of here are tied directly to our workflows, but the pre-processing comes in down in the bottom right here are the user-submitted videos that have been processed. We drag these into the screen. We use, in this case, Tiger Woods. I guess you guys can't see my laser on the ground here. We use Tiger Woods here in this example, compare him to him, and then we provide a really rich golf experience for him. The coach, he records this, has some audio over the top, draws some fancy lines, and then the end product are some videos. Each one of these web lessons is typically between 3 to 10 short videos. So what were our challenges before we introduced AWS and Simple Workflow specifically? So we were a traditional data center, right? We had racks and racks of servers to manage our workflow. We were limited by scale, being able to grow, and some glaring capital costs from storage and just processing power. The implementation we had was basically a simple workflow server, and then it's a web server that handled everything. It was very dangerous and scary, and it kept me up at night. And then as well, we had a spaghetti factory of PHP scripts that basically ran rampant all over the place with numerous errors or with just no logging. We had no idea when something broke down aside from a customer contacting us, and that's not the best feeling, right? The biggest challenge we had, though, is we were getting backlogs. So we process about 3,000 lessons a day, which equates to about 30,000 videos. So we had a backlog. We just couldn't keep up with the demand, and our business is growing, and our partner Sports Illustrated obviously has a big megaphone to get us some business, and we weren't able to service that. So what do? We brought in AWS and Simple Workflow. It's a fairly busy slide, so I apologize here. I want to bring out two items this was our old infrastructure. So basically in the top right up there, you can see we had two basic app servers, and these app servers did a lot of the transcoding. So when you get in 30,000 videos, you have to do a lot of transcoding. And then as well, they were also our basic app servers. So they were part of the problem, if you will, the spaghetti factory. We also had just a SAN storage and 1 to 10 terabytes of golf videos at the time. So fast forward to basically now, and this is much prettier, obviously, and there's a lot of services we use from Amazon Web Services, and the two we're just going to continue to talk about are workflow. So now we have two decider pairs, nodes that we use, and we have 8 to 20 workers that we deploy. So those manage the load. We're often able to process these lessons that come up in a matter of minutes as opposed to measuring that in hours, and that's a huge thing for us. Someone could come in and take a golf lesson, leave and get to their car, and their actual web lesson is ready, and that's very powerful for us. It's great for our customers. We've also spun up as many as 200 of these worker boxes, and that was to process our old golf lessons. So our old golf lessons were in legacy media. We had Flash at a certain point in time, and we needed to go back and rip through those, and we were able to do that quite successfully and at a cost that I could swallow. The other part here relative to our previous architecture is storage, right? So we had 10 terabytes of SAN space, basically 2 of them, right? You always have to have a backup. We moved everything to S3, and we're up to about 200 terabytes now. So we have a ton of golf videos, some good and some bad. Mine fall on the bad side of that. So what do we learn? What benefits do we have? I could probably talk for days or the next 41 minutes as we have for what we gain from using SWF and AWS, but for us we have a methodology of no lesson left behind, and what that basically means is every day a customer comes in, they give us their money, they get a fantastic golf lesson, and they expect the product also at the end of that. Prior to using Simple Workflow, we had no methodology of retrying a failed lesson upload or putting something back in the work queue or the workload in an automated fashion. We basically heard about the problems from the consumer, and that's just not acceptable. So now we have a fantastic GUI. Our tech support guys can go in, right-click on a lesson, and replace it anywhere back in that previous slide workflow in the upload status and the pre-processing status, and it can be presented to the customer. And then the last bullet here for me is that flexibility, right? So we are able to grow tremendously now. We plan to open up a number of golf tech locations in the United States and across the world, and this has been a huge benefit to us. We're basically limited by our creativity. We have the scale now, we have the ability now, and you know, smart guys. My head engineer's back here. His name's Quinn Perkins. Him and his team can basically do anything under the sun now, thanks to SWF and Amazon Web Services. So that's it for me. Thank you very much for your time. I'm going to pass it back off to Sanjay.
Thanks, Ryan. Appreciate that. So next, I'd like to invite Jeff Winter to talk about how he's using Simple Workflow at Cardspring. Thanks, Jeff.
Hi, I'm Jeff Winter. I'm the CTO of Cardspring. And originally thought I might not have a question for you guys to help you relate to what I do, but I do have a question. How many have used a credit card to buy something? And, oh, some people haven't. It's surprising. Anyway, so what Cardspring is we're an API. I think I want to go to the next slide. We're an API, and essentially what we do is we let developers write applications that find out when credit card transactions take place. So if you're one of our publishers like Foursquare or Yahoo or someone like that, what you do is you tell us about a merchant, you tell us about a credit card, and then we look for that credit card to be used at that merchant. And when we see that credit card to be used at that merchant, we tell you. We do a webhook back out to you. We're a part of the authorization process for the credit card, so we also have the ability to take discounts and to put messages on the receipts, and everything happens in real time. And so that's fundamentally what our service is. We're kind of hidden. We're part of a lot of applications on the web right now. We have tens of millions of cards. We see tens of millions of transactions a day. But we're really a part of the infrastructure. We're not something that you're going to see in front of you. And so we've used AWS from the beginning. We're about 3 years old. We're the smallest PCI Level 1 compliant company ever, largely thanks to AWS, which handled a lot of the issues for us. And we're like totally great believers in AWS for all the reasons that little companies like AWS. So when we integrate with the financial systems, we have to have a system that's extremely reliable, which is why we've always been multi-zone, multi-region from the day we started, which enabled us to survive the great apocalypse on the East Coast when all the data centers went down. We did not go down thanks to AWS. Anyway, so we integrate with a lot of these legacy systems, and what we do with these legacy systems is we integrate in all sorts of ways. We use SOAP, we use whatever protocols they use, we do batch files, we do multiple different formats of batch files with different ways of transferring those files around, and I'm sure you can see that that starts to imply a workflow. The other thing that we do is that we have API calls. For example, we have one publisher that has 30 million cards with us, and they'll do one call that will take 30 million actions. And so we can't, of course, do that synchronously through a REST-based API, or it would be a disaster. And so that's another case where we would be a good use for a simple workflow. When we originally built the system, we built that around publish and subscribe, and we essentially built the workflow ourselves. And so this is how we worked. We used Jenkins. Jenkins is essentially a little job scheduling system. And what that did was it talked to the ELB, and the ELB talked to workers, and the workers would do things like pull a giant file with 30 million transactions and run all the way through it and stop partway through, and we would never know where we could pick up again. We would not know when it was going to be done. We wouldn't know how far along it was. So that wasn't really optimal. And then the other thing that we did was we would do these calls from the API. Someone would say, add this offer to 30 million people, or take this offer away from 30 million people. And we would say, okay, got that, and we could never tell you when it was done. We couldn't tell you that it happened to everybody. We couldn't tell you that it was removed from everybody. We could just have this job that ran, and if it crashed at all partway through, then we would not know what was going on, and we couldn't run it again. What made our system even more difficult is that we work with many, many external providers through many different mechanisms, and they're not always available. And so it's not that we only had to make our own systems reliable. We had to make our system work when a service we're using wasn't there. We had to go back and pick up and do that work again. And so our original design using publish and subscribe probably wasn't a great design to do that, and we moved to simple workflow. The move to simple workflow was like of earth-shattering importance to us, right? It's really made our day-to-day lives much, much better. We can run all of our batch jobs. We run them reliably. We know where they are. We can pick them up from the middle, all those sorts of things. The other thing is that the migration was extremely easy. We're Ruby on Cassandra, and we developed a methodology, and we just moved one workflow at a time. And so we actually were able to live in a world where we had both systems working. And we just migrated one workflow, developed a library that would do that, migrated another workflow. And we had already sort of naturally come to the idea of workers and deciders in our software originally. And so that migration was also pretty easy. We just finished migrating our last jobs. We have about 30 or 40 different workflows that run through our system to do the integrations with our various financial providers and then to provide for the sort of bulk-oriented API operations. So, summary of why we did it is that we are in a system where we must be up all the time. We must be reliable. We can't forget things. Even in a batch operation, it's not good enough to get 99% of them. And where things fail all the time. And so we needed those abilities from simple workflow to manage the task, understand the progress, scale the task, and then pick up in the middle and go from there whenever something does fail. So that's it.
So Jeff talked about the resilience and the consolidation and easy management that Simple Workflow brought to Cardspring. Next, I'd like to invite Andrew Ryan to the stage, or to the front, to talk about how MemberSuite is using Simple Workflow for their use cases.
Thank you. All right, how many of you guys like air? Air fans, anyone? All right, everyone let out with a hand-raising question, and I didn't want to be different. So, MemberSuite, what we do is we provide software to automate the back-end processes for associations and nonprofits. So it turns out that if you're an association, you've got members, and you've got all these problems that for-profits don't have. You've got to sort of manage renewals and expirations and billing. You've got conferences like this that have to tie back into your membership. You've got to manage sessions and logistics. You've got to manage fundraising, certification, and continuing education. We have over 20 different modules to solve these problems, and we work with mid-size and larger associations that can't use, say, a small Excel spreadsheet or a custom-made Access database because they're just too large. It turns out that this is actually a pretty big problem. We have over 100 customers, and we are a C#.NET SQL Server shop. They still let us present, but we are. So we use every little bit of Amazon Web Services as we can. We started out kind of, in the no man's land of hosted bare metal servers, and we came through Rackspace Cloud and finally transitioned to EC2, and we use everything. We use Elasticache for our distributed caching. We use Dynamo for our sessions and cart management. We're obviously using EC2. We're using S3 for storage of files. We're using Cloud Search to encode those files, so when our customers have publications that they put out that need to be searched, we do all of this. But out of all those services that we use, my absolute hands-down favorite, the thing that was just, when I saw it and understood it, blew me away, is Simple Workflow. And it solved a really big problem that we had, because we have all these long-running processes in our product that have to do things that may take longer than an API call, right? We have to worry about billing and recurring billing and email blasts and file processing and media uploads. And the thing that I'm going to talk about today, though, is order processing. At the end of the day, we're sort of an order processing system. You're a nonprofit and you have all these different products. And if you buy a membership product, you should go get a membership. It should expand dates or deal with that, whatever. If you buy a fundraising product, a gift should be on your record. If you buy an event registration product, you should get registered for something. If you buy a subscription product, you should be subscribed. And our product has this complex workflow. And so what we did was we built our API, which is, we used the principles of domain-driven design. So we had in there our domain, and we had a thin API layer, and then we built a separate, what we call job execution service. And they all talked into a shared database. And for a while, it was good. And then we got that whale customer. You guys know what I'm talking about. It's that customer that sales and marketing is crazy about, but engineering is kind of looking around like, how big are they? And it's like the bank calling in your technical debt, right? Because essentially it's exposing all of the compromises you made in your architecture. And this particular customer came in and had 14,000 of their members run orders at the same time for their renewals, and brought our system to its knees. I mean, on its back, legs in the air, dead as disco, right? And so we had one of those that was like what we call a job finding problem, meaning like my CTO who's over there kind of looked at each other and said, if we don't solve this problem, we're going to have to go find jobs, right? And so we knew that we were kind of in trouble. And the way that we were using our architecture, we were doing all these workflows, even though they were in a separate service, we were doing them through kind of big SQL transactions. And we were kind of cheating because we didn't have to worry about compensating logic when something went wrong. If something went wrong, SQL would kind of roll it back. And we knew that was no good. And so we started off by using Quartz.net to kind of do our scheduling of our recurring tasks. And we started using Microsoft Message Queue. And it was okay, it worked, right? The problem with message queuing was that we had these sort of dumb queues that would take messages, and we'd have to write code to move things from one queue to another. And so the workflow was really in the code that was handling the message of the queue, so we couldn't reuse things that the queues were doing. It was sort of you know when you build something, how many of you are engineers in here? You know when you build something, you know when you build something you don't really feel good about yourself? You check it in, but you know it's just not quite, that's what it was like. And the real big problem was that we couldn't scale MSMQ. For some reason, Microsoft Message Queuing Server, accessing remote queues on a different server is almost, if you Google Stack Overflow and Google my name, and you will see me on there posting, why can't I get Message Queue to run on separate boxes? So we just knew it wasn't the long-term solution, and we had to look for something else. And so we ended up migrating to Simple Workflow Foundation. And at first, Amazon Simple Workflow. And at first, I sort of was hesitant. What is this? How does this work? There wasn't really a .NET API for it. And we ended up diving into it. And within about a week after a proof of concept, we knew that this was the solution. We ended up modeling everything we did as a workflow, getting rid of queues altogether. And one of the great things about it was that it really forced us to design well. So it forced us to think about our order process and cut them up into manageable chunks. So for us, when you process an order, you have to write it to the database. Then you have to go and make sure the credit card is valid. Then you have to go and write all the invoice and payment records to the database. Then you have to go and fulfill it. That might mean creating a membership. It might mean extending a membership date. It might mean registering for an event. It might mean subscribing you to something, whatever, or it might mean all of those things. Then we have to go and actually capture the credit card. Then we have to go and send emails and confirmation. And it forced us to kind of break our logic up into sort of manageable chunks. And when we did that, we realized, wow, we can write compensating logic and we can think really hard about how to back out of certain situations depending if there's a failure. So for instance, what do we do if the credit card fails? Easy, right? Well, what do we do if something's wrong and the credit card processor is unavailable? Or what do we do if there's a database lag or a timeout? We could actually compensate for that and retry. We could actually say, you know what? If there's a problem with the database or it's not available, wait a minute, try again. We could never do anything like that when we were running these big transactions. So what we got was sort of scalability and reliability. And if you see now, the way our architecture looks is when you run a process in our system, you're actually just making a call to our API, which is kicking off the workflow. And then we have our job execution services have migrated from these sort of ugly, evil Quartz.net sort of Windows service, stop in the middle of the night and nobody knows why, so you just restart it and you don't really know why it's broken, but it works, so you do it, to just a collection of really elegant workflows that are sort of really well thought out. And the thing we got that we did not expect, that really was just icing on the cake for us, is we got for free distributed processing. So it might turn out that different parts of the same workflow run on different servers. And that's okay, right? That's fine, who cares, right? They're all stateless. We didn't even anticipate that we'd get that going in, but what it got us was robustness. A job server could die in the middle of an order and it doesn't even matter. We just replay it somewhere else. We also got the ability to isolate certain functions to certain servers. So you see here, we've got JES1, JES2, and then we've got JES files. Because part of what we do is when somebody uploads a file to our system, we actually don't store it, we send it to S3. But then we want to encode it so we can get to it with cloud search, and that's a workflow. But if somebody uploads 10,000 files, we don't want that to make order processes start to slow down. So we start to allocate workflows to certain processes and boxes, something we also could never do before. So we are completely thrilled. Key benefits, we don't have the crashes anymore. The job service stopped, we don't know why, somebody restarted. I mean, those kind of things where you're just kind of rebooting things, you don't know why, but it works. We kind of were able to eliminate that. And we also were able to sort of codify all of the long-running things that we did into workflows that we could manage. So all of a sudden we had visibility into what happened, for instance, with an order. Customer would call and an order would fail. Before, we didn't know why. I mean, we had no idea why it failed. Support couldn't deal with it. Engineering kind of said, I don't know, pick a reason. But now we can actually go into the console, look at the order, observe the workflow, see why it failed, and say, you know what, let's just rerun this, or let's rerun the last 10. And that is unbelievably powerful for us to be able to do for our customers, and eventually for our customers to be able to enable to do for themselves.
Mm-hmm. Thanks a lot. So I'd like to share a few more customer stories with you, and I think I'm going to steal that Dead as Disco line. That's a good one there. So next, yeah. So Fluid is a longtime Simple Workflow customer. They were here with us at reInvent last year, and I wanted to share some new applications of Simple Workflow that they're doing. Fluid does high-performance image processing. Their customers include Reebok, JanSport, the ones you see here, of course, but also Brooks Brothers and Vans. So they have some pretty well-known brands that they have to keep happy and service. What they offer is a solution that gives brands shoppable images and their end users dynamic images to navigate and to browse. So they have an imaging and virtual product customization suite that they give to their and e-commerce customers. And they're Java-based shop. They use their Java Flow libraries, which are the top of the stack in that 3-stack diagram I showed you, the Java Flow framework. So before Simple Workflow, Fluid would generate 3D images using a third-party package called Reality Server. And then after they got those images from the Reality Server, they would then stitch them together with their admin master server in order to create this navigable 3D image. Under load, this became problematic for them. A single product represented 1,000 images, and this led to poor performance and scalability, and in some cases, many, many hours to process a single product SKU. After Simple Workflow, they've been able to parallelize both the 3D rendering as well as the post-processing of those images. So they set up a set of workflows that listen on task lists in Simple Workflow. They've got the 3D rendering listening on one task list. That's a Simple Workflow concept. And they've got the post-processing listening on another task list. And what they do, they're able to split the work out among those server pools. And if they begin to notice that certain pools are getting behind, they can auto-scale and catch up with the processing that they have to do. So, as I mentioned, what this brings is parallelism both to the 3D rendering and the post-processing. With this architecture, their processing times have gone down by 30 to 80%. Imagine what this means for this architecture now. Imagine the number of customers now they can support with this new architecture. As I mentioned, key benefits for Fluid include that the processing times have dropped from 30 to 80%, and they can auto-scale their worker pools based on the load that they can inspect using CloudWatch metrics and auto-scaling. Next, I'd like to talk to you about ConnectWise. ConnectWise provides ERP for IT service providers, professional services companies, networking companies, people who do time and materials-based services. They have 5,500 customers with over 80,000 end users, and they have 4 worldwide data center locations, and they're running Simple Workflow within their data centers. So their key features include trouble ticketing, time billing, calendar syncing, and then they also do deployments across their server farms and their data centers using Simple Workflow. So before Simple Workflow, they had single-purpose servers that were dedicated for each customer. And for each of those customers, they would process email updates and calendars on a name basis, A through M, N through Z. And they had this standalone workflow system that was responsible for trying to move things in their ticketing system from one state to another. They also had an installation system, and this relates to what I talked about, them needing to update their server farms with the latest software that they license to their customers. Logs were stored on each machine, and server utilization was unbalanced. As you can imagine, one customer might be more active than another customer for various reasons, based on their size, based on their time of day, etc. After Simple Workflow, ConnectWise runs over 100,000 workflows a day and runs over 1.5 million activities and decisions using Simple Workflow. They have homogeneous worker servers now that do the processing work. So scaling for them is a different beast. They can simply add machines with a workflow engine that is consistent across all of those machines. They have centralized logging to Amazon S3, and they have geodiverse workflows with a very heterogeneous technology architecture. They've got Java Flow workflows, and then they've got .NET activities that are actually executing the work. So they have this hybrid technology infrastructure, which allows them multiple benefits, including having specialists who can work on certain things in .NET and having other workflow writers that can work on things in Java Flow. So, key benefits for ConnectWise. Cost and utilization has been a big thing for ConnectWise because now they have these consistent architectures with homogeneous servers. And simplified management is a big deal now. So instead of having log files distributed across multiple machines, they have a single view of what's happening in their architecture, what's happening in their workflow. Similar to what Andrew talked about, being able to look into the console and see what failed, what needs to be restarted, what happened in the past. They have that similar benefit with ConnectWise. They're also able to split complex workflows across these identical worker servers. And getting back to the key benefit of Simple Workflow, these worker machines now can be stateless because there's a single state store in the cloud that they can go back to get the next thing that they need to do, and that's Simple Workflow. Finally, I'd like to talk about Lyft. Lyft, how many people are familiar with Lyft in the audience? Yeah, Lyft or Uber, they're an Uber competitor. Lyft offers a ride-sharing and virtual carpool service. 80% of their customers are repeat customers, which is a big deal. I think any company would love to have that. Their average rides are under $10, and they have over 100,000 users. And they're a Python shop. So Lyft has a multi-step workflow for enrolling private citizens. Private citizens are drivers for Lyft. This workflow includes uploading a picture of a headshot, taking a picture of your car, getting a photo of your license, consenting to a background check, doing some online training, and then finally, once those steps are complete, going out with a driver on a mentoring session. These processes, as you can imagine, can be long-running, right? I may upload my headshot before I do my license photo, or vice versa. So at any point in time, a customer may enter the workflow at different steps. And the processes are long-running. They can fail at any time, at any step. They could have solved this problem with queues and processes that read off these queues and scheduled them to periodically check if a certain step is done, and if not, perform the step that needed to be done. Lyft decided that this would have been brittle for them. And around the time they were building this system, they discovered Simple Workflow. So their system is built from the beginning on Simple Workflow. Lyft's architecture consists of one workflow worker, a decider, and one activity worker. These things handle application updates. They do reminders to the driver via email and SMS. So they have transport on the other side of the activity workers where they're sending email and SMS to drivers to alert them to complete the various steps in the application that they need to complete. Lyft does many, many, many thousands of applications per day, and they do it with one decider and one activity worker. So the key benefits from Lyft that they've shared with us is they're able to audit the workflows. They know what step a particular driver's application is in at any point. And that comes from the simple workflow concept of history. We store every step that has happened in the past, and the decider operates on that history in order to understand what to do next and what came before it. Lyft also gains flexibility. As a few of the customers on stage have talked about today, they've been able to iterate on what this workflow needs to look like. In the future, if they need to add an additional activity that does other checks in this driver enrollment workflow, they can, without having to rip out all the logic that controls the flow from one step to another. So, summing up, today you heard about 7 of the many use cases that simple workflow can help solve. There are many, many more. We talked about them a little bit earlier. Content moderation, Bazaar Voice showed us what they're doing with content moderation. GolfTech is doing some interesting things with video processing. The work that Jeff is doing with post-transaction processing in Cardspring is quite innovative and amazing, especially when having to interact with legacy infrastructure and legacy businesses. Member Suites order processing that Andrew talked about. Image processing with Fluid, business and IT automation for service providers with ConnectWise, and then partner enrollment with Lyft. What does simple workflow offer you? What can it bring to your applications? What can it bring to your end customers? With simple workflow, you can get scalability, you can get flexibility, you can get resilience, performance, simplification, cost, and efficiency. How and why? Because we allow you to abstract the state machine from your applications and focus those units of work on the tasks that they do best. And simple workflow means the central state store so that at any given point, if any one of your worker nodes fails, another one can pick up and know what to do next. With that, I'd like to thank our illustrious customers for joining us today. They're doing some interesting things, and hopefully next year, some of you will be on stage with us to discuss your use cases and how you're using simple workflow. I think we have a couple of minutes, so we'll be around. Can take questions. Our development managers from Simple Workflow are here, Assad and Rick. So if there's some deep dives that you'd like to do, we're happy to field them now. And then go enjoy a beer, of course. So.